Yeah, I'm not ready to go back tomorrow.
No, I imagine not. I'm sure I'll hear that a lot from my students.
Yeah.
Okay, let's see. We left off question number 3. So let's start with 4. Let me see if I can get my thing centered here. There we go. Should be better. Incidentally, as far as that website goes, you shouldn't have to keep going back to that.
It doesn't save on my computer. I don't know why. Like, I downloaded it and everything, but I don't have it saved.
I doubt that it re-downloaded it. It probably, the moment you asked to re-download, it probably found the version that's on your computer and ran it.
Okay.
Because it didn't seem like it took enough time from when I answered your text to when you came on. So I don't think it downloaded anything. It's got it on your system. You may have to go and run it or something, or try to find out where it's at. I don't know. But I guess this works. If you go to joingotomeeting.com, it'll find it on your system. So.
Yeah, I'm like, I don't know. I guess spring break. I forgot what it was called.
Okay, that's fine. All right, can you read that number 4 okay?
Yeah. So we're just writing an equation for it?
Well, they're showing you the expression that if you had to solve this on your own, you'd come up with one of these before you got to the final answer.
Yeah.
So they don't care about it, the actual average. They want to make sure that you know what it means. How do you find the average price? What is the average price going to be?
$8.49 or?
No, because there's a $20 charge for the first one.
Oh.
And then there's 5 others that are on sale for this much each. So average means what? Let's talk about average. If I said to you, what is the average of these 4 numbers, what would you do?
I would, I don't know. I think I'm thinking about like medium or something. Or.
Okay, to find the average of a group of numbers, you add them all up and divide by how many numbers you got. So it would be 7 plus 9 plus 10 plus 12, all divided by 4.
So it's like finding the mean, or?
It is the mean. The average and mean mean the same thing.
Okay.
Okay, so how would we find the average for this? When you think of average, always think total. Okay, because almost inevitably, when you are given an average problem, whether it's a mean or average, you're going to have to find totals. That's the key to all average problems. So what would the total cost be here?
So wouldn't you do like $20 and then do $8.49 and then divide it by 6?
There you go. In other words, there's the total, and there's 6 DVDs. So that's answer G.
Okay.
Okay? Hopefully the next one will be a little clearer. Ah, it is. Oh no. I think it, oh no, it wasn't. It was a little bit lighter, but it wasn't that much clearer. I'm going to have to get another camera that does a little better job. It's just...
It's a little blurry, but I can read
It's,
it.
I know. You can make it out, but it's just hard on the eye. It's hard trying to focus that hard. So he's got 18¼ feet of lumber. No, he needs that much, and he has 10½ feet. So how many more feet does he need? Do you have your calculator handy?
Yeah.
Go ahead and get it out. Get it set up. And any problem that you can do with your calculator easier than manually, let's have you do that. This happens to be one that can be done with the calculator pretty fast, pretty easy, and always accurate.
I don't think I'm setting it up right.
So what do you need to do? How many more feet do we need? How are we going to figure that out?
Don't you subtract it?
Okay. So you can do it this way on a calculator, which is a little hard. What's the better way to do it if you're doing it on a calculator? Convert everything to decimal.
Oh, I don't remember how to do that.
Well, what's 18¼ What is a quarter in decimal?
0.25.
Okay, so that's 18.25. What's 10½?
10.5.
Now do that on your calculator. What do you get?
7.75.
Which is which answer?
C.
Uh-huh. Do you know how to, there is a, what kind of calculator do you have?
I have the TI-84.
There is a button on there that will automatically convert fractions to decimal and decimal to fractions. If you take that answer, 7.75, and you hit, let me get my calculator because it's been a while since I've been on that calculator. If you hit math, does it present you with an option that says fraction?
Yeah.
Go ahead and hit fraction, and it should say 7¾
Oh. That saved me a couple seconds.
Okay? So that's a good way to toggle back and forth between fractions and decimals when you need to.
Okay.
Okay? Obviously, we could do this manually. It's a little tough manually because 1/2 is greater than 1/4. So we kind of would have to do it this way. 17 5/4 minus 10 2/4. You see what I did there?
No.
Well, I took 1 out of the 18 and made it 4/4. So 17 5/4 is the same as 18 1/4. The advantage is now the fractional part is bigger than this fractional part, and you can do this manually. That's clearly 7 3/4. 5/4 minus 2/4 is 3/4. 17 minus 10 is 7. But there's no reason to do all of that work as long as they're going to let you use a calculator. This is a perfect problem to use it on.
Yeah.
The last time we met, you made a couple of comments that led me to believe that we need to have a little check on a couple of things. Tell me what, without using your calculator, what that is. That's a 9.
Oh. 16.
Okay, now tell me what this is. You absolutely need to be able to do all of these without a calculator. Absolute must. To be successful at mathematics, you have to be able to add and subtract positive and negative single-digit numbers. So if you can't do that, let's go through it and make sure you can do it. So what's minus 9 plus minus 7?
Wouldn't it be like 16 too?
It's negative 16. When you add two minus numbers together, you retain the minus. If I was multiplying minus 9 times minus 7, it would be positive 63. So a lot of people get confused that thinking that two minuses make a plus, but they don't if you're adding them together. What is this?
Isn't it negative 2?
Yeah, if we are adding a positive and a negative number, we're basically going to subtract the two numbers and put the sign of the bigger number with our result. So that's how we do it. Just use a little formula. Okay, so finally, what is this? Hold on, sorry. Again, a negative number added to a positive number.
Would it be positive 2?
Yes. In other words, again, we're going to subtract the two numbers and we're going to put a sign of the bigger number on it. So there you have it in a nutshell. If you can do those 4, then you can do all subtraction problems, because subtraction can always be turned into an addition. Now, obviously, we don't need to turn this into addition to do it. What is that?
2.
And what is this?
Negative 2.
Correct, because whenever you subtract a bigger number from a smaller number, you have to have negative. Now, here's the ones that give people problems, these two. What is that?
Isn't that positive 2?
No. Here's what I want you to do whenever you see a subtraction problem involving negative numbers. Not these first two cases. These involve nothing but positive numbers. You know how to do both of those. But whenever you have a subtraction problem that involves a negative number, I want you to turn it into an addition problem. The confusion for this with everybody lies in the fact that these two dashes mean different things. This dash means a negative 7. This dash means subtraction, not a negative 9. That means subtraction of a positive 9. So if I'm going to turn this subtraction problem into an addition problem, I just change the subtraction sign to a plus, and I change the sign of whatever was being subtracted. So now it becomes the same problem that we did in addition. What is negative 7 plus minus 9?
16.
Negative 16. You have to get the answer, the sign right, otherwise, obviously, you're not going to get the answer right. Okay? And then finally, if I have a positive number subtracting a negative number. What is that?
Negative
No,
2?
do what I said. Take the subtraction problem and turn it into a negative, an addition problem. Well, here's the subtraction sign, right?
Yeah.
So we're going to change that to an addition sign, which I can do as long as I change the sign on whatever was being subtracted. Well, it was a minus 9, now it's a plus 9. So now what's the answer?
16.
Yes. That's all there is to it. Okay?
Easy.
All right. The reason that it doesn't work in math to have to be able to do those on a calculator is because when you're solving algebraic equations, a lot of times you have to make a lot of small single-digit additions and subtractions. In other words, every time I have a problem like this, I have to subtract 2 from both sides. So if I don't know how to add and subtract single-digit numbers, I'm lost, okay? And you can't rely on your calculator for this. You just can't. You'd have to have it strapped to your eyelids. That's how often you need to do these when you're doing typical algebra. And nobody wears that calculator on their wrist, so the only way to be able to do math is to be able to do that stuff in at least the simple stuff in your head. Nobody expects you to be able to do, this in your head. That's fine to have to do that on a calculator. But 2 minus 4, you need to do that in your head. Okay, so here we have 3 to the x equals 81. Then what is 2 to the x times 2? The key is to be able to solve that for x. Once you come up with what x is, then substitute it for over here and come up with an answer for that. So how can we solve that for x? It's a little different. That's not an algebraic expression. It's an exponential expression. And the variable is in the exponent. So just know this, that when they give you a question like this, the answer is always going to be a small whole number. It's not going to be 2.1. It's not going to be 4.6. It's going to be 2, 3, or 4. Maybe 5. So,
4?
So x equals 4. What that means is 3 times 3 times 3 times 3 equals 81, and it does. It's the same as 9 times 9. So now that x is equal to 4, what is this on the right, which is what they're asking about? They didn't really ask us to solve for x, and yet they put that answer on there. A lot of people are going to pick F because they're only going to solve for x and they're not going to look at the rest of it.
Wouldn't it be 4 again, but...
Well, now I have 2 to the 4th power times 2. Now, if you don't know what 2 to the 4th power is, you can do that on your calculator. You know how to take a number to a power on your calculator?
Yeah.
Okay, take 2 to the 4th.
16.
Now multiply that by 2.
32.
That's the answer.
So it wouldn't be 4, it'd be 32.
Exactly. 4 would be x, but notice they didn't ask about x. They asked what 2 to the x times 2 was. So we have to substitute that 4 that we came up with for this x right here. Okay, here we have a very straightforward geometry problem. We have a rectangular garden that is 60 feet by 25 feet. What's the length of the fence that goes around it?
Won't you just like do base times height?
That's the area.
Are we finding the perimeter or?
Well, what would we be finding if it asks for the length of the fence? The fence is there, plus there.
So when did you do 60 plus 60, 25 plus 25?
Yes.
$170.
Like I said, very straightforward. This is definitely a problem. You need to know the perimeter of a rectangle for sure. You need to know some of the basic stuff you absolutely have to know is the area of a rectangle, the perimeter of a rectangle, the area of a circle, and the circumference of a circle, which is the same as the perimeter of the circle. All right, in this expression, they want to know what this would be equal to if x is equal to minus 6. So what am I going to do? How am I going to solve it?
Plug x in?
Yeah. So tell me what the next line I need to write is. Precisely.
6 squared.
X is minus 6.
But doesn't the negative and the negative cancel out?
Well, that's why I wanted you to write it for me, because here's what we have. And this is the way you should always do these problems. Do not skip a step. You invariably, if you skip a step here, you're going to mess the sign up on one of these numbers. Now, this part right here, is that squared operating on this first minus sign?
No.
Is it operating on the negative 6?
Yes.
Okay, so what the full circle I have, what should I now replace that with?
Okay, negative 36.
Negative 36, precisely. In other words, this minus right here was never being squared. Okay, and what comes next? What is this all equal to?
Positive 12.
Good. And plus 21. Now, you can get that on your calculator if you want. Let's make sure you know how to do that on your calculator, because it can be a little tricky using negative signs. Especially on that TI-84, there are two signs that look like subtraction. One is meant to be a negative sign, and it's to be used in questions like this. In other words, if you do this on your calculator, the way you should do it is you want to hit that first negative sign. Again, let me look, make sure you know which one I'm talking about. The lower right white key. You see that negative sign?
Yeah.
That is different than the gray subtraction sign. And if you want to solve this problem, to put in the negative 36, you have to use that lower right negative sign for starters. So you would hit negative 36, and then the gray plus sign, 12, and then the gray plus sign, 21. What do you get?
Negative 3.
Yeah. Now, try it by hitting the gray negative sign and 36. And then plus 12 plus 21. Does it still work?
Yeah.
Still gives you negative 3?
Yeah.
Okay. I've seen problems where the difference between those two negative signs is critical, and you have to know which one. Apparently with this one it didn't matter. But the negative sign that has the parentheses around it is not subtraction. Okay? Alright. So -3 was our answer. So we have volume equals 4/3 pi r cubed. And they're saying there's a ball that r is 2 inches. What is its volume?
Is this one the one where you use like 3.14 for pi, or do you just ignore pi?
You can put it in as a, you can't ignore it, but you can either put it in as pi, there's a key on your calculator that says pi, or you can put it in as 3.14.
I didn't get the right answer.
What'd you get?
33.49.
Okay, which answer would you pick?
D.
Correct. Notice that it said to the nearest cubic inch. So it actually asked you to round up, or round it.
Okay.
So you did get it right. However, just to point it out, two cubed is 8. Now, you can't really do this, but since all of their answers are spread apart pretty good, I can cancel that 3 with that pi. And I got 4 times 8. So my answer has to be 32 and change, just using an approximation technique. If I know my answer is 32 plus, it has to be D. There's no way 32 and change is 96. There's no way it's 25. So you don't really need a calculator on this.
Does that work for everyone?
You know, it works an awful lot. I would say that, and I'm going to be totally honest here, the calculator is a hindrance more than a help unless you really are terrible at multiplication, division, addition, and subtraction. Most problems, like this one, the calculator is going to hurt people. I can do this faster without a calculator than you can with one, merely because I look at the answers and I know approximately where it has to be. Pretty easy to come up with 32 plus. Once I come up with that, all I have to do is check my answers and I know the answer.
Okay.
And yes, I would say that is pretty standard. It's rare. I would say out of the 60 questions, maybe 2 of them are going to benefit by having that calculator. But there'll be another 2 that the calculator will lead you astray. If you had a problem, which is on a lot of ACT tests, where you have something like this, it is going to be, in my opinion, easier to do that manually than it will be on a calculator. Now, perhaps with judicious use of that key that lets you switch back and forth between fractional and decimal might be easier on a calculator. But the trick to this problem is to add the three fractions. 1/4 plus 1/3 plus 3/8. And knowing how to do that. Now you could do that part on a calculator almost, although you had some problems adding fractions before, so it depends on your skill in converting these to decimals maybe. I don't know. I'm just saying that don't think of the calculator as a giant edge. It really is not.
Okay.
Now, if it can speed you up and save you 20 seconds by using it, then by all means you want to do so. But it can't always. So, which of these expressions is equal to that? And the way to do these is to just go through each one. In other words, start with F. Is that equal to that? No. Then G, and so forth and so on. So is F correct?
No.
G?
Uh-uh.
H?
No.
J?
No.
You're done with the problem. Mark K and go to the next one. That's where speed is definitely an issue because you do not want to waste the time solving that. Once you've eliminated 4 answers, the 5th one has to be correct. And
Okay.
2 times that would be 4C minus 2D. So it is correct, but you don't always have to spend the time verifying it, if you know what I'm saying. Those seconds are going to be precious. You want to be able to save as many as you can. Okay, so you received $20 on your new job. You received $20 plus a fixed amount for each lawn that you mow. Currently, you are earning $95 per day mowing 5 lawns. How many lawns are you mowing? Just with that information. In other words, that's not what they ask. They ask something different. But in order to be able to answer this last 2 sentences, you need to be able to figure out how many lawns you're mowing to earn the $95. In other words, you need to figure out what you get per lawn.
Okay.
So what is that? If you earn $95 for 5 lawns, but your salary is a fixed $20 plus a certain amount per each lawn, what do you get per lawn?
Don't you divide it so it's like 19?
You got to get rid of that initial 20 first. That $20 you got for showing up on the job is for no lawns at all. You show up on the job and go home, you're going to make 20 bucks. You also get a certain amount per lawn. So how would you figure out what you get per lawn? How about if we subtract that 20 first, because that doesn't have anything to do with anything. So you made $75 mowing 5 lawns. How much did you make per lawn?
$15.
Okay. So your salary is $15 per lawn plus 20. Flat 20. Okay, so now we're ready to go on. Today you mow an additional 2 lawns. What will today's earnings be?
$125.
Good. all the problems on the ACT are two-step problems. It's really going to be an easy problem to only require one step. You're not going to see that very often. Most of the problems are going to be like this, where first you have to figure out how much you're going to make per line, and then you have to answer their question. And you can't answer the question until you know how much you make per line. So it's kind of, you want to keep that in mind, that almost always there's going to be a second part to the problem. Well, here's a case that's not that way. In other words, this is a one-step problem here, 12. Which of the following is simplified? Well, let's just take their expression and simplify it and see what we get. What do you do when you simplify an expression that has multiple variables?
Either add them or subtract them, or you put them together.
You can add or subtract like terms only. In other words, I cannot add y to x and simplify it. That's equal to x plus y. Okay? But if I said x plus x, that's equal to 2x. If I have one apple and I add another apple, I got 2 apples. So the first thing you want to do is gather all the like terms. So what are the total amount of x's that we have?
3.
Well, I got 4 there. I got 2 there. How many is that?
Oh, I thought you meant like how many x's were in the equation.
No. No, I meant how many apples. If x is an apple, how many apples do I have?
Oh, that's 6.
What about this one?
And then that's 5.
So we have 5x plus, we only had 1 y, so there's our answer. Do we see that? Yeah, G. And in this case, multiple choice doesn't really help very much. There's no way I can use this problem would have been exactly the same with or without multiple choice. You just have to perform the operation on that and find the answer. Back solving wouldn't help here a bit. Okay. Which of these equations does not represent a line? Can you spot it out by just glancing at all 5 of them?
B? No, E.
E. Correct. Because there's an x squared. Whenever you have a squared term, you are looking at a parabola. Either that way, or this way, or this way. But it's not a straight line. It's a curved line. Whereas all the rest of these are straight lines. Let's make sure you know. X equals 3 is this line right there. 2y equals 7 means y equals 7 halves. Well, y equals some number is a horizontal line. In other words, that would be y equals 7 halves. So vertical and horizontal lines are x equals and y equals. C, well, that's in almost perfectly in y equal mx plus b format. So I would know I could divide both sides by 1 and I get this. Well, that's a straight line because it's in y equal mx plus b format. D, that's a straight line because that's in y equal mx plus b format. Even though there's no b, there is, it's just 0. But that's still a straight line. Slope of 3/4. All right. It looks to me like they didn't quite draw this to scale. They want the value of angle B. A is 40 degrees, so let me draw it here. They intentionally misled us by not drawing it to scale. They are evil. So I won't draw it to scale either. What do we know about the lengths of these lines?
Do
we know anything about them at all?
No.
Actually, we do.
Oh.
What are AC and CB? What are those relative to that circle? Radiuses. Right?
Okay.
Isn't AC the radius of that circle?
Yeah.
So is CB?
Yeah.
All radiuses are equal in the same circle. So no matter where I draw a radius, that line's the same length as CA or CB. So what does that mean? That means that's the same as that, which makes that an isosceles triangle. So in this isosceles triangle, where two sides are the same, what else is true about an isosceles triangle? If two sides are the same, what about the opposite angles?
They're the same too.
So this is the opposite angle of this side here. This is the opposite angle of this side here. These two have to be equal. They've told us that's 40. Angle C. So what now? If I know that this is 40 degrees and this is equal to that, what must one of these angles be? What do the angles of a triangle add up to be?
180.
Okay, so let's start with that. So all three angles add to 180. So A plus B plus 40 equals 180. So what is angle A?
When did you subtract it?
Subtract the 40 from the 180. So we have A plus B, which is the same as A, equals 140. So now we have two angle A's equal 140. What does one angle A equal?
70.
Uh-huh. There's your answer. In other words, there were a lot of principles at play here. A lot of things about geometry you need to know to be able to get this problem. First of all, you need to know that all radiuses are equal. And I don't know about you, but it sure looks like they've made that one longer than this one.
Yeah.
But still, all radiuses are equal. It's probably an optical illusion, because I don't know how they could do that. That circle looks pretty round.
Yeah.
So all radiuses are equal, which makes this an isosceles triangle. Isosceles triangles not only have two equal sides, but the opposite angles are equal also. So now the problem becomes, okay, here's a triangle. This is 40 degrees. This angle is equal to that angle. How to go from there? Well, you could do a little bit. If you didn't know how to lay it out algebraically, like I did, just do a little trial and error. At this point, you can test the answers. I think. Yeah. In other words, let's look at those 5 answers they gave us there. Well, could 80 be right? Well, let's see. 80 plus 80 is 160 plus 40, that's 200. I need a smaller number. Okay? Just do it that way. In other words, once you realize that that's an isosceles triangle, you can then back solve it. And 80 won't work, but the next one you'll try is 70. So that's 70, 70. Do those 3 add to 180? Yes, they do. That's the answer.
Okay.
Okay? Okay. This is an important principle that you understand this question right here. If I give you the following problem, what is x equal to?
10.
If I give you the following problem, what's x equal to?
X, Y, or X and Y? No.
One of them has to be 0. X is equal to 0 or y is equal to 0. In other words, whenever we're multiplying 2 things together and they equal 0, the way you solve it is by setting one of them equal to 0. So now tell me this. What's x equal to?
1.
Aha. Notice the pattern. What's y equal to?
2.
No.
Oh, -2.
Okay. So the pattern is that when they give you a solution set, the answer is always the negative of that number, right? In other words, had I started out by telling you that x minus 1 times y plus 2 is equal to 0, you would have said that means x equals 1 or y equals plus -2. Well, they're just doing it backwards. They're giving you the solution set first, and they want you to come up with which 2 things are multiplied together. So what would it be in this?
Would it be D?
Would you say?
D?
D, as in David. Yes, it would. In other words, if you had to solve that, you know the answer are x equals 5 or x equals 6, and that's what they've given you to start with. Okay. Plug in x equal 1/2 and solve this. And tell me what to write. Do it step by step.
So it'd be 1 over 1/2 plus 1 over 1/2 minus 1.
That's always the way you should begin these. Don't take shortcuts. Okay, now what is that equal to?
Two.
Yes. So we have 2. What's this equal to?
2.
Plus 2 minus 1. What's that equal to?
3.
Good. Very good. What is this equal to? Or tell me how you would do it. And don't use your calculator.
I would plug in 2/3 and then divide it by 3/4.
So how would you do that without a calculator?
I would make the denominator be the same.
No. If you're adding or subtracting fractions, you have to find a common denominator. When you are multiplying or dividing fractions, it's the easiest thing in the world. It's far easier than adding or subtracting. It's similar to the subtraction problems. Turn all division problems into multiplication problems. How do I do that? That's the same as 2/3 multiplied by the reciprocal, 4/3. Now just multiply across, 8/9. Multiplying is so much easier than adding. If I had to add 2/3 plus 3/4, I'd have to go through the process of finding a common denominator. That's hard. But when you're multiplying two fractions, just multiply the tops, multiply the bottoms. And if you're dividing fractions, turn it into a multiplication problem. Always. That's the only way we know how to do division. Nobody's ever taught me how to do that division other than this way. It's the only way I've ever learned. It's the only way I even know how to do it, is flip the bottom and multiply. So, that being the case, what's that?
So you would flip it? So it'd be 3/1 and 2/1?
Okay, right now it's 3/1, and we're only going to flip the bottom. You don't flip both.
Oh, so 1/2
Times what?
1/3.
What's that?
2/5. 2/6. 1/6.
1/6. Again, multiplying and dividing is easy if you remember that rule. Even when the denominator is not a fraction, like this case here that I just gave you, you can still solve it by flipping and multiplying. And in fact, this is the easiest way to really understand it, is doing that. All right. We got time maybe for one more here. No, let's not make it that one. We'll come back and do 17 and 18, but these are both pretty difficult.
Okay.
More than we have time to do right now. I'll make a note though. We'll do these two the first thing at our next session. 18 probably isn't even hard. It's just very wordy. But again, wordy problems aren't always hard problems. A lot of people can assume, in other words, the first time through the test you come across this, you may put a double check mark next to it and go on. That would be a mistake. You want to at least read it. It may be pretty easy. This turns out that it's not going to be that hard at all. But we'll still come back to it. What does this mean? What's that called?
It means that everything...
It's absolute value.
Yeah.
Absolute value. So they're saying the absolute value of x is greater than the absolute value of y. So which of the following must be true? One of these 5 statements has to be true. Does x have to be greater than 0?
No.
No, because if I had absolute value of minus 5, what is that?
5.
That would definitely be greater than the absolute value of 2. That would be a true statement, right?
Yeah.
So x doesn't have to be 0. We just proved it by finding an x that was negative, and yet this statement still is true. So that's not it. Does x have to be less than y?
No.
Okay. Can x be equal to y?
Yes. No.
No, there would have to be that there for it to be equal to it. They're saying absolute value of x is greater than the absolute value of y, therefore there's no way they could be equal. If I set the same number in here as here, then that's not going to be greater than that. X cannot be equal to y. Is that true?
No.
It is true.
It is?
Yeah, we just proved it. In other words, when we proved that C could not be true, that makes D true.
Oh.
There's no way X can be equal to Y and have this statement still be a true statement. I mean, just plug in, pick a number. If I pick 17, the absolute value of 17 is not greater than the absolute value of 17. They're the same. So X cannot be equal to Y is the one truth that always has to be the case. And of course, X doesn't have to be greater than Y. We showed that because the absolute value of minus 5 is indeed greater than the absolute value of 2, and yet X is actually less than Y. But still, that would be true.
Okay. So it's D?
Yeah.
Okay.
All right. Let's go ahead and wrap it up. I will make a note. And when is your ACT?
April, I think the 23rd or the 25th.
Okay, so we're still going to get 2 or 3 sessions in
Yeah.
before your test. Good. Good. All right, I will text you next Sunday at 6.
Okay, thank you.
All right, Lauren, have a good week.
You too.
Bye-bye.
Bye.